Hi dears, this is chapter 1, Motion, and it's on page 11. Let's start. First of all, the objectives are to define the position of an object in a given frame of reference, define the motion of an object, define the trajectory of a moving object, to know the two fundamental types of motion and its combination. Activity 1, page 12. We will observe a boy sitting on a bicycle in figure 1a, and you have some trees here in the background. And in figure 1b, we will notice that the boy starts cycling and the bicycle start moving on the ground. Observe figure 1a and 1b. In figure 1a, the distance boy tree does not vary. This is the boy and this is the tree, for example. Part 1. Does the position of the boy relative to the tree change? The answer is no. Is the boy at rest to a relative to the tree? The answer is yes. In figure 1b, the distance boy bicycle does not vary. The boy and the bicycle have constant distance between them, while the tree is in the back of the bicycle and the boy. Is the boy at rest relative to the bicycle? The answer is yes. The distance boy tree changes. Does the position of the boy relative to the tree change? Yes. Is the boy in motion relative to the tree? Yes. What is the reference in this case? The reference is this case that we are using the tree. Is the tree in motion relative to the boy? The answer is yes also. If the boy look at the tree, he will see it going far away from him. What is the reference in this case? The reference is the boy. To describe any motion, we need to choose the reference first. Conclusion. Motion needs a reference to be described. An object is said to be at rest if its position does not change with respect to a reference. An object is in motion if its position changed with respect to a reference. The trajectory. Activity 3, page 14. I will summarize it. If you darken a piece of glass by the flame of the candle and then let any object to fall on it, it will describe its path. If you incline the piece of glass, the motion would be inclined. Sometimes when moving, you leave the position of your steps behind you. And sometimes this happens for the planes. Sometimes the trajectory is not visible. What is the trajectory? The trajectory is the set of positions occupied by an object during motion. The two fundamental types of motion. First one is the translational motion. And the translational motion includes the three types, by the way. The second fundamental type of motion is rotational motion. Let's start by the translational motion. Consider this object, and I want to observe these 2 points on it, and I will observe the motion or the path of these 2 points if I translate this object to this position. Please look carefully that the trajectory of the first point is parallel to the trajectory of the object, and the trajectory of the second point is parallel to the trajectory of all others. This is the definition of translational motion. In a translational motion, all points in the solid have identical or parallel trajectories. In a translational motion, we have types. The first one is rectilinear translational motion, in which the trajectory of all points are parallel straight lines. Curvilinear motion. If you allow this object to move in a curve, also the trajectory of each point is parallel to the other in curve. Identical to the other curved trajectory is the motion in which the trajectory is a curve. Circular translational motion. If I allow this object to move in a circle about a certain fixed point, for example, the object and this point, the distance between them is the radius of the circle. If I allow this object to move in a circle, it will move in a or far away from a constant radius. If I allow it to circulate about this point again, it will move at a constant radius from the center. This happened to a car, for example, when going around a round. But look at the trajectory of all the points. They are circles. Simply circular translational motion is in which the trajectory of any point is a circle in it, or in which the trajectory is a circle of the object. Rotational motion. This is the second fundamental motion. If I allow this ruler to move about this point and I take into consideration these 2 points, if I will rotate this ruler about this point, look carefully please at the 2 points. Look carefully at the 2 points. And let us trace their trajectories. Their trajectories are constant circles, not any circles. They are concentric circles about the center. This if the ruler rotate about itself. This happened to a wheel, this happened to your arm if you make it to rotate. Rotational motion in which all the points in the solid have concentric circles trajectories. Now, what will happen if I consider the combination between rotational motion and translational motion? For example, consider this wheel and this point. If I allow the wheel to rotate, the motion of this point about the wheel is circular. But look at the trajectory. The trajectory is not a circle. And if I observe the center, sorry, if I observe the center of the wheel and I allow the object to move, the center of the wheel is moving in rectilinear translational motion, while all the points circulates about or rotates about the center. This is the combination of rectilinear and rotational motion, or translational motion and rotational motion. The definition is the combination of a rotational motion of the solid about its axis in the middle and the translational motion of the axis of the solid. This happened in the motion of the earth about itself and about the sun. It rotates about itself but circulate or translate about the sun. And this is for any wheel moving on the ground. Thank you, dears.